Right, in this lesson, we are going to review factoring, how to solve by factoring, as well as the quadratic formula. So just to keep in mind, we're talking about solving things that look like these examples down here, right? They've got exponents, potentially multiple versions of the variable, right? You've got x squared, x cubed, maybe. How you solve those is different from, say, how you'd solve something like this, right? A linear expression, I can just isolate the variable and solve for x. But when I have powers, I have to do some things differently. So we are always hoping to solve by factoring because it is definitely quicker and easier than using the quadratic formula. So let's just sort of review your basic steps when we're talking about solving. So, for example, the first thing you're going to do if you're solving an equation that has a power greater than 1 is put it in order and on the same side of the equal sign. The second step you're going to do is look for any greatest common factor that you could either pull out or divide out of the equation. And then after you do those first two initial steps, then you have a decision to make in regards to factoring. First of all, it depends on what you're left with, right? If what you're left with is two terms on one side of the equation equaling 0 on the other, then you're going to have to choose between whether or not it's the difference of squares or maybe the sum or difference of cubes. If either of those are possible, those are methods of factoring. So just to refresh your memory, difference of squares looks something like that. X squared minus 9, I have two terms and they're both squares. That would factor as x minus 3, x plus 3. Same terms, different signs. And then if they're not perfect squares, it could be that they are the sum or difference of cubes. Notice there is only a difference of squares. Cubes can be a sum or a difference. And as you look at the two terms, if you notice the two terms, this is not a perfect square. It's a perfect cube. 2 cubed is 8. And so how I would finish that problem, I cube root both terms. Cubed root of x cubed is 8. Cubed root of 8 is 2. And then my second factor here is the first term squared, x times x. The two terms multiplied together, and then the last term is squared, which would be plus 4. And I didn't really acknowledge the signs. I just put a negative there. So hopefully some of you remember, maybe you learned SOAP. Same, opposite, always positive is an mnemonic to help you remember what you do with the signs with the sum or difference of cubes problem. So the first sign is the same as the original. The second one is the opposite of the original. And then the last sign is always positive, just as a quick reminder of how difference and sum of cubes works. If it is not a two-termed expression that you're solving or equation that you're solving, then perhaps it's 3 terms. And if you're looking at something that's 3 terms, then you might just do basic factoring, right? That's this something that looks like x squared plus 6x plus 6, right? You give yourself 2 parentheses. The first 2 items have to multiply to give you x squared. The last 2 items have to be something that multiplies to give you 6. Could be 2 and 3. It could be 6 and 1. So I also have to consider the middle term. It has to add to give me 6. I said it backwards again. It has to multiply to give me 6, but add to give me 7. So 2 and 3 are actually not going to work. I would have to make that 6 and 1. 6 and 1 will work. And if I want them to be positive, I put plus and plus. So that's your basic factoring. Hopefully you remember that. Or if it's not a basic factoring question, perhaps you have to do bottoms up or split the middle term or guess and check, whichever method that you learned. And that looks like something like this, right? What makes this not a basic factoring question is this 3 out front. I no longer can just put x and x as the first 2 terms in each of my factors. I have to actually take care of that 3. And probably one of the more popular ways to handle that is a method called bottoms up. So if you remember that, I'm going to multiply, get rid of that 3 by multiplying it with the 2 and make that a -6. And now I can just factor as normal. I keep hitting the wrong button. Sorry about that. Let me put that back there. All right, so -6. So I'd end up with x and x. 3 and 2 will work, and it needs to add to give me a +1. So I'll make the 3 positive and the 2 negative. Now, that wasn't a 6, right? It was a 2. So if I multiplied by 3 here at the end, I do have to divide everything by 3 to kind of take back what I started up there at the beginning, make it fair, balanced. I have to pay for my multiplying off that first term of 3. And when I do that, I get 3/3 reduces to 1, and 2/3 does not reduce, so I move the bottom up, hence the name bottoms up. But that is how I would factor something that has a coefficient in front of that first term A. Now, you have one additional option. If you have something that is 4 terms, then you're going to factor by grouping. Factoring by grouping question, I'll show you an example of that, and I'm running out of space here when we do one of the examples. And then the last term, when you're going to solve, right? So 2, 3, 4, and 5 are methods of factoring. And then if I have to go one step further and actually solve the problem, then I want to set each factor equal to 0 and solve. Basically, at that point, you're talking about if you have 2 things that you're multiplying that you know equals 0, and actually it doesn't have to be 2 things. If I have a list of things, A times B times C, and I know that when I multiply them, I get 0, then I know that either A equals 0 or B equals 0, or potentially both. And I can solve. That's the principle of zero products that we apply here. So let's look at a few examples. Now, I also want to just denote the difference between all of these are equations. They all have equal signs. The directions say solve. But I know in your practice, I did give you some practice of just factoring questions. And sometimes students don't notice the difference between those 2 things. So let's solve 3, and then I'll show you what it would look like if it just said factor. So as I go to solve this, I notice I've got 3 terms. Step 1 says move everything to the same side and put it in order. So I'm going to move that 6 over. It's gonna become negative on the left side of the equal sign. I notice it's 3 terms, no coefficient in front of the x. So this is just basic factoring. I know this is x and x. And 3 and 2, where the 3 is negative, the 2 is positive. Because they have to multiply to give me -6 and add to give me -1, so that will work. Now, I have factored at that point, right? So if the question originally was not a equation, if it's just an expression, there's no equal sign, you wouldn't see the directions to solve, you'd see directions to factor, and all you would do would be this part. X minus 3, x plus 2. Done. That is your answer if the directions say factor and it's not an equation. If it's an equation, then you're going to take it one step further. Here's your A times B equals 0. So I know that either A, x minus 3, has to equal 0, or B, x plus 2 has to equal 0, and I solve both. So my 2 solutions would be x equals 3 or x equals -2. Both of these solutions, when I plug back into the original equation, will make it equal 6 on the left-hand side. All right, try the rest of them. Pause the video if you're feeling pretty good about factoring, and see how you do on the rest. All right, if you're coming back to check now, I see I already don't have to worry about step 1. Everything is moved over to the same side, and it's set equal to 0. I look for a greatest common factor because I can see there's a few things, but 4 and 25 have no common terms, so I cannot divide out a GCF. So I notice there's 2 terms. It's either the difference of squares or cubes. And it looks like both 4 and 25 are perfect squares, so I am dealing with a difference of squares problem. Square root of 4x squared would be 2x, and the square root of 25 is 5, and one's going to be positive and one's going to be negative. Now, if I was factoring, I'd be done, but since I'm actually going to solve, I know that either of these terms equaling 0 gives me a solution. Subtract 5 divided by 2, and I get negative 5 halves and positive 5 halves. So those are my two solutions for x that will make that equation true. All right, C. Again, move everything to one side. Put it in order, descending order by exponent. So I'm going to leave the 2x squared first. When I move the 5x over, it's going to be negative, and the 12 is going to be positive, and it'll equal 0 on the right-hand side. I do not love that my first term is negative, so I'm going to divide the whole thing by a negative 1, which will change all of my signs. 0 divided by a negative is still 0, so I don't have to worry about that. I really wish I could factor out that 2, but 5 obviously is not divisible by 2, so I can't. This is a bottoms-up kind of question. So let's multiply by 2. And I'm going to give myself that little note in color so I remember that's what I did. I'm going to end up with x squared plus 5x minus 24 equals 0. I'm going to factor that. I need two things that multiply to give me 24 and add to give me 5. So 6 and 4 doesn't add to 5, but 8 and 3 does. If I know they're going to have different signs because that's negative. And the 5 has to be positive, so I'll make 8 positive, 3 negative. Now, before I finish, remember we multiplied by 2 up there at the top in red. I need to pay for that. I need to undo that. So I'm going to divide both of my terms by 2. The first term reduces to x plus 4, and the second one does not reduce, so I pull the bottom up. And then I go to solve. X plus 4 equals 0, or 2x minus 3 equals 0. Both will give me solutions. So solving for x, I get negative 4 and positive 3 halves. All right, D. Everything's on the left. It's set equal to 0, and it's in order. So steps 1, there's no GCF. 2, are done. Now I'm just looking at how I want to try to factor this. There are 4 terms, so hopefully I can factor by grouping. So here's the review of that. Factoring by grouping means you group the first 2 terms together and the second 2 terms together. That negative sign, definitely, I'm going to make that a plus, a negative there, so I don't forget that that 4 is negative. And then I look at my 2 terms. My first term, I see I can pull out an x squared. I pull out a greatest common factor, which is x squared, and that leaves me with x minus 3. My second group of my second group of factors there, I can pull out a negative 4, which leaves me with x minus 3. Now, if this is done correctly, these two should be the same. That's a big clue that you've done it right. And now I'm going to factor out, pull out front that x minus 3, because I essentially have 2 terms, this one and this one, and they both have an x minus 3 in them. So I'm going to pull out the x minus 3, and when I do that, I'm left with, trying to make the right color, x squared minus 4. Now, x squared minus 4 can be factored a little bit further. That is the difference of squares. So don't forget to do that. When you're done factoring, hopefully you won't have any powers left. You'll have linear factors. And I know that if these 3 things, when I multiply them together, equal 0, then one of them must equal 0. And I get my 3 solutions. 3, 2, and negative 2 all will work as solutions for that problem. All right, we have 2 more practice problems. In E, I notice I have everything on one side, everything's already to the left, and everything is in descending order. Now, I do have a GCF, and if that was a constant, like if my GCF was a number, I could divide it out of the whole problem, but I do not want to divide out a variable ever. When I do that, I'm going to lose one of my solutions. This is a power of 4 equation, so I should end up with 4 solutions. They might not all be real. Some of them might be imaginary, but I should definitely end up with 4, and if I divide out the x, I'm only going to get 3. So when you see a GCF that is a variable term, you're going to want to factor that out. So that leaves me with x times x cubed plus 27. I see this as 2 terms. It's definitely not difference of squares, but if I check, both of those are perfect cubes, so I factor x minus 3. I don't know why I changed it to minus, it's plus. And then I get my second, my trinomial piece of this. It's the first term squared, right? This guy squared. X times 3, opposite sign. And then 3 squared would be 9, and that's always positive. So remember your signs, same, opposite, always positive. All right, so now I have 3 terms. Something you should know, this is not factorable. It never will be. If you do the difference or sum of cubes factoring, that trinomial term won't ever be factorable. So I can get 2 of my answers pretty easily. I know from this first one that x equaling 0 would give me a 0 for that first term. X equaling negative 3 would give me a 0 for that middle term. And then this last piece, since it's not factorable, I have to go to the quadratic formula. So I know we didn't list it anywhere earlier. Here's your quick review. If you don't know it, you do need to know it. If you're going anywhere in math, the quadratic formula pops up too often. It's worth having memorized. If you don't have it memorized, there is this song, and I will sing it to you just because I care. You'll see why I'm a math teacher and not a singer, but this does not shame me. So here goes. X equals negative b plus or minus square root b squared minus 4ac all over 2a. That's the quadratic formula. To pop goes the weasel. Learn it, live it, know it. So as I go back over here to this trinomial, I can see my first term a is 1. My first coefficient, not term, is 1 on that x squared. B is the negative 3. C is positive 9. And I simply plug all of those things in. A negative 3 is a positive 3. 3 squared minus 4a. C, and I know the 3 was negative, and negative 3 squared is positive 9 also. Notice the b squared is going to put that whole thing in parentheses. And then 2a, and now it's a matter of just simplifying. I'm going to get 9 minus 36. Oh, it's going to be imaginary. All over 2. 9 minus 36, I'm pretty sure is 27. All over 2. So I do have a little bit of reducing here. 27 has a perfect cube hidden in it, and I'm going to pull out an I. So hopefully you've had some review that negative is going to be an I on the outside. 27 is 9 times 3. So the square root of 9 is 3, and then that one leftover 3 will be left inside. And my denominator is 2. And I can see these terms, 3, 3, and 2, cannot reduce each other, so I'm going to leave that as my final answer. So remember, we had a 4th degree polynomial. I got 4 solutions. X equals 0, x equals negative 3 are the 2 real solutions, and then I have 2 imaginary solutions for the other 2. All right, F. Looks like no GCF. Can't factor out that 2. Looks like it's a bottoms-up problem. I'm going to go ahead, times 2, and try to factor but there isn't anything that multiplies to give me 2. My options are 2 and 1, and that's it. And adds to give me 4. So this is not factorable, which means, again, the quadratic formula. So let me sing it for you one more time. Sing along if you'd like. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So I grab that. I can see a is 2, b is 4, and c is 1. I plug it all in. This time it's not going to be imaginary. 16 minus 8 all over 4. Negative 4 plus or minus 16 minus 8 is 8. Now be careful with your reducing. I find that most students can get here. You know, if they know the quadratic formula, this part isn't the problem. Doing all that math isn't the problem. The problem is simplifying. And I suppose our next topic on radicals will help a little bit with that. But I have 2 things to do. First of all, this can be simplified. And if you're doing that on your calculator all the time, you need to stop. Learn how to do this without a calculator. You're going to, especially if you have to go on beyond, if you're taking more math, stop being so calculator dependent. The square root of 8 is 2 times 4. And 4 has a perfect square. So I'm going to end up with negative 4 plus or minus 2. That 4 became a 2 on the outside. Radical 2 all over 4. So that reduced my radical. Now I do have to reduce. I've got 4 over 4 and 2 over 4. These are reducible fractions. But notice, I can't just reduce one of them. I have to do all of it. This is like the distributive property. That 4 gets divided into both pieces. A lot of times what I see students do is they just cancel out these 4s because they're like, oh, 4s cancel. Well, yeah, they do, but you can't do that just to the first term. That denominator of 4 belongs to both the numerator and the denominator. This would be negative 4 over 4 plus or minus 2 over 4, rad 2. So don't just cancel off the 4s. You also have to reduce that 2 that's in front of the radical. So negative 4 over 4 would be negative 1 plus or minus, well, okay, square root of 2 over 2. That's one way to do it. I've split them up. If you don't like that, some people would have just said, hey, let's reduce all of these by 2. That's the only thing I can reduce by. So I get negative 2 plus or minus root 2 all over 2. These are the same thing. If I got a common denominator here and added it together, I would get this. So it's just a matter of whether you're splitting the fraction up into 2 terms or leaving them together. Both are correct. All right, that is your fast review on solving polynomials by factoring and the quadratic formula. I'll see you later.